Welcome back, Course 1 Math. Today's lesson is called Lesson 2, Multiplying Whole Numbers and Money, Dividing Whole Numbers and Money, in the last part of Fact Family. So a continuation of last lesson, except instead of adding, subtracting, our operations are multiplying, dividing, which in a really real sense are shortcut operations. If we didn't have them, it would be a lot of addition, subtraction. It would be very time consuming. So actually, even if you don't like math facts or long division, multiplying, any of those things, really you should be thanking them for existing because they do save you an immense amount of time. Let me show you this new first concept. Courtney wants to enclose her square garden. Worth mentioning that it's square right off the bat based on what we know in geometry about what a square is. That already is telling us something when they share that information. And they've already started to draw it here. And if you were to be doing this problem for homework, you'd be drawing it yourself if they didn't give it to you. And they want to know, with this vegetable garden that's a square, how many feet of fencing does she need? Okay. They've given us this drawing, and they tell us it's 15 feet aside in the square through the drawing. And they want to know how much is that total. We could do that a couple ways. We learned adding, putting our addend 15 together all 4 times, 1, 2, 3, 4 sides in a square would give us, you'd have to line up, right, your tens and ones, and, or use a calculator, I suppose, and you would get, this is 20. And then 2 plus 3, 4, 5, 60, right? And that was a little bit more time consuming than it needs to be, is what they're saying. 4 times 15 is 60, is what we call multiplication. If we have 15, 1, 2, 3, 4 times, we can times it by 4 and get 60. And the way we carry out multiplication is I usually put whatever number has the most digits on top to look like this. Times sign is that X, usually, at least when you're doing it longhand this way. 5 times 4, this is just memorization that you should have by now in whatever grade, 5th, 6th, 7th grade. We should know 20 is 5 times 4. We write the ones place here, and then the tens goes on top of the 1, and then after we did this, now we do this. 4 times 1 is 4, plus 1, 2 is 6. And that's multiplication. And as they show, that comes to 60. And just like we learned addends, sum, minuend, subtrahend, difference, in multiplication you have what are called factors. And what's great, kind of like in addition, that's the same word depending whether it's 4 or if it's 15. They're both called factors. They're the numbers that you multiply. And the reason we don't need a separate term is because, like addition again, this is going to be the type of thing that you can rearrange. What was the word we used for, in this case, 2 factors can go in either order to come to the same answer? Well, that word was commutative. And we'll say it's a commutative property of multiplication today, meaning we can put these in either order. We still get 60 as our answer to a multiplication problem. So we call that a product. The answer or solution to a multiplication problem is a product. To indicate multiplication, we could use this sign, the way they did here. L times W stands for length times width. Or you can use a dot, which also means times. Or you can just put the 2 letters, length, width, next to each other, and that also means multiplication. Now, if you do that with numbers, what's the problem with doing this means 5 times 4? I just stuck the numbers next to each other. Because it looks an awful lot like 54, which is not the same thing. So when you're actually going to use a number, you're going to use a parenthesis if you ever want to just stick them next to each other. You can't ever really truly put them just next to each other. That's why I like the dot. It's pretty quick. So they're showing that length times width means something. It's not what we did here. What was this measurement where we did fencing all the way around? We just found perimeter. But if we did length times width, or 15 times 15, well, then we're finding what's inside here. And that's called the area. Okay? Area is square footage, or whatever it is inside. Okay? Inside part. Okay? So length times width gives you area. Length times number of times it occurs, or like 4 sides, is perimeter. Now with a square, we could also say 4s is the perimeter. 4s meaning 4 times how many sides is the perimeter. So perimeter in a quadrilateral will be 4 times the sides. So 4 times sides, if they're 15, you plug in the 15 where there was side. And the perimeter of a figure with a length of 15 for a side is 60. If the side is 9, then you plug in 9 for your s. S is 9. And that means 30. So perimeter is the same as 4s. Area is length width, LW. For a square, you could also say, since the sides are equal, s squared, s times s, is the area of a square. Length, width, height, that's volume. We're not there yet. Now, let's see what else they have here for us. Multiplying a double-digit number, we multiply twice. First, 28 by 14, and then 28 by 4. Then we multiply, or to multiply 28 by 14, we first multiply 28 by 4, then we multiply it by 10. Why do we multiply 28 by 4 by 10 and then add? Because we multiply by the value of the ones place and then by the value of the tens place. And the value of this place is, this first ones place is 4. So we multiply by that. And the value of this place is right now 10. So we multiply by that and we put them together, or else we won't get the right answer. So here they do 28 times 14. So you multiply like we would normally do. If you're pretending that this 1 isn't here, we would do 8 times 4 is 2, or 32. So you write the 2 and the 1s, you put the 3 up here. 2 times 4 is 8, plus 3 is 11, right? So it's like a 2-part answer. 11 and 2, 102. Then you have to put a 0 here. Now we're dealing with tens. So 1, 8 is really 80. And then 8, 1 times 2, this 3 no longer applies to what we're doing, is 2. And then we add down here. 2 plus 0. Is that a mistake there? Let's double check on our calculators. I'm wondering if 28 times 14 doesn't come to an answer with a 2 in the ones place. Books can make mistakes, folks. So now I'm allowed to this year. I see a number that should be a 2. 2 plus 0 is 2. 9, 3. Wow. I think that's interesting that they would let that happen. Yep, it's wrong in my book too. Now, how can we check if we get the right answer besides using a calculator? I like calculator. You could also check by doing 14 times 28 because multiplication is commutative. And since they're both two-digit numbers, I don't think that's so weird to put 14 on top. Now, if you're multiplying with dollar signs, $1.35 6 times would be 30. 18 plus 3 is 21. 6 times 1 is 6, plus that extra 1 is 8. Don't forget to put your decimal in. Now notice, how do we know where to put the decimal? Well, maybe it's because you're thinking $1.35 6 times is not going to be as much as $81, so it makes sense to call it 8. But there's a way we can know how that works. When you're multiplying with decimals, let's clear all this out. You count how many decimal places there were to start, and you apply that to the end. This is really where the decimal is in the 6. So there's nothing to the right of the decimal there, but there are 2 places to the right of the decimal here. So being 2 places there, we'll make sure that there are 2 in our final answer. 1, 2, and sure enough, right there we put it. Okay, watch that we do that for future ones as well. Find the cost of 2 dozen pencils at 35 cents each. They use the cent sign. What's another way to show 35 cents but with a decimal? And that might help make sure that we put the right decimal in the answer because we don't like to say 840 cents. Really, 35 cents with a decimal looks like $.35. Or you could even show it as $0.35 or $00.0035, however you want to do that. Now you notice you don't have to line up your decimal place with multiplying. We're multiplying. So you do that. This is where my decimal is over here. We count how many there are for future reference. There's 2 spots. That's what we're going to need in our final answer. And then they do all that work for us here, where you're going like this and then going like this. Carrying numbers as needed. Add the ending and 1, 2. Decimal goes here because there were 2 spots to the right of the decimal in the original factors. Make sense? Pause, replay that if any of it is needed. Commutative property, 4 times 2 is the same as 2 times 4 in multiplication 2. The identity property of multiplication states that if one of 2 factors is 1, the product equals the original factor. The zero property of multiplication, 0 gives us a 0 if 0 is a factor. So I'm gonna put those in here. Commutative property of multiplication. Identity property of multiplication. And the zero property. And since we already know commutative, I'm just going to show you the other 2 one last time. Identity property, oops, misspelled. Forget about that one. 5 times 1 is 5. Notice I used a dot for my multiply sign. We can do that now. Zero property says that if one of my factors is 0, I get 0. Finally, maybe we can show factors in orange, and let's try green for what's the name of the solution in a multiply problem. In multiplication, the solution is not a sum or difference, it's a product. So in orange, I'm color coding factors, and in green, let's use product for multiplication. Don't forget that. Wrapping up here, multiplying with zeros like this one. Trailing zeros doesn't change the product. They reverse the order and write trailing zeros so they hang to the right, and then you don't have to do those extra steps. I've always just, I guess that's a good thing to think about. If you've got these extra zeros, you could set up the 4 to line up here and then just toss the zeros on at the end. Feel free to check that out on on page 13, or no, page 14, if you want to learn more about that. Last, with dividing here, in division, I love this right here. They show you the different ways we can see division, and what are the terms for a division problem? Dividend, divisor, and quotient. Where dividend, divisor, quotient. The quotient is the answer of a division problem. The divisor is what's doing the dividing, so it's going into. And the dividend is the biggest number of all usually because it's the number under here, under the overhang. In carrying out division, you look at 5. Does it fit into this 1? No. So do we try 5 into 15? 5 times 3 is 15. 5 fits in 15 3 total times, giving me an even 15. 5 times 3 is 15. Nothing left, so 3 remainder 0. Just a straight 3 there. You can also use the division sign like that or a factor bar to show division. When the dividend is 0, the quotient is 0. When the dividend and divisor are equal, the quotient is 1. I'll show you that one. That just looks like 5 goes into 5 one time, not 5 times, right? You can't do this. I guess you can. They said that the dividend is 0, you can do that. I don't think you can do this, really. I don't think I would attempt that. So they divide 7 into 3,456 here. 3, 4, 5, 6. I like that. Divisor is 7. It doesn't fit into 3, and it doesn't fit into 34, so we have to attempt 7 into 345, which might help to use a calculator to come up with that one. How do they kind of figure that? Oh, you can put 7 into 34. My mistake, missing slip of the tongue there. I was thinking, well, 7 goes into 35, not 34. Well, then we just get as close as we can. It can't always be even the way this was, right? So it can't fit 5 times 35 is, so we have to do 4 times into 34. And that's 28. We write it there. Subtracting, have to borrow. This becomes a 2. This becomes 14. 6, 0, or whatever, nothing. Bring it down. 7 into 65, I'm thinking 9 times 7, and this is why your multiplication facts are so important, that you can do this with automaticity, automatically. Bring down your 6, 26, I'll fit 7 3 times. 21 into 26 leaves a remainder of 5. 493, remainder 5. This was called long division, what I just did. And that's what I typically use in class. If you didn't follow, maybe watch it over again or read over the way they show it on page 15. When dividing dollars and cents, cents will be included in the answer. What if we're putting, like, if we have $3.60 and I'm asking how many times can I divide 4 into that? 4 doesn't fit in 3, but it does fit in 36, 9 times evenly. Now what's going to happen with that decimal point right here? Well, with division, your decimal simply raises up. It's pretty simple. You can do it even before you get started. This dot belongs right. Oh, that's not what I wanted. It goes right. Oh, whatever. It rises right up there, such that 1 second. Oh, I see. Okay. Rise it up here, right there. Okay, go straight up, so we get 90 cents if this was a dollar sign. Okay. Wrapping up here. Fact families with multiplication division. Since you can rearrange multiplication, it works a lot like when we had adding, subtracting. Maybe you want to show with a triangle again. Your fact family. And let's see if I got this better now. Nope. Well, 5, 12, and 60 is a fact family. Let me show it on my pad over here. If 5 times 12 is 60, then I have a fact family for multiplication division. Whereas my addition subtraction one was maybe 12, 5 is 17. I like these, especially for multiplication division here. Now this is telling me that a product of 60 could also be rearranged for another multiplication problem because commutative property. But then I could also move products to become dividends over here, like so. 60 divided by either of my factors will come to the other number. See how that works? 12. Or final fact family fact here, 6 divided by 12 is 5. This would be nice for missing number problems, okay? Fact families work for multiplication division as well. Kind of like yesterday or last time, why don't you pick one of AB, pick one from, how about pick one ABC, pick one DEF, and then do G and H for 4 total problems.